So in this lesson we're going to understand the law of reflection and use reflection to draw ray diagrams for mirrors. We'll be looking at two types, convex and concave. So the law of reflection is simply light being reflected when it strikes a surface. So when you're trying to reflect light from a surface, you need to know that the angles that the light comes in from are taken from the normal. If you remember what that is, you'll mark on whichever the surface is where the light strikes it. So we can see that it strikes it there. So then from there, you will draw your normal. Just a dotted line at a right angle from the surface. This is our normal line, which we've done in class. And the light should reflect outwards like that, at the same angle that came in. This angle in here should be the same as this angle out over here. So if you were to measure that angle, of course you'll measure it from the middle, from the normal all the way to the end. That here will be the same as whatever this side would be. So the law of reflection just states that when light is reflected, the angle of incidence, the angle incoming, is equal to the angle of reflection, the reflected angle. That is simply the law of reflection. If this is 40, then this is 40. However, sometimes they might give you this angle. This is 50. You do not use this. Of course, if this is 50, that's also 50, but that's not the angle we are using. We have to use this angle. So we would use 40. If you know that this is a right angle, you'll remember you can just do 90 minus 50, which gives us 40. Amazing. So we'll use that here in this example. So a ray of light coming in, which row shows the correct value? So of course you will have your dotted line, your normal. It will be coming out like this. So if this is 40, yes, this is 40. That's not good. The angle should be here. This is the angle I need. This is the angle reflected. So 90 minus 40, this will be 50 in this case. This will be 50 as well. So angle coming in and angle coming out, 50, 50, there we go. So E would be the answer here for us. Another example, which way would the light go? As you know, the angle coming in is the same as the angle coming out, so we would know it would go in the direction of C. So we'll measure the angles using a protractor, or we'll measure it from the normal. Alright. A mirror will take all of these lights, all of these rays of light, and because it's curved, it'll end up focusing at a point. And we call that point the focus, funnily enough. So this is how light will be reflected in a mirror. You will have many, many lines. You do not need to use all of them. We can get away with using just 2 lines to figure out where the image would end up being. So if I had an image, you would have like an arrow or something, and you want to know where the image would be. First thing we would have is a straight line to the mirror. The second thing you'll do is a straight line through the focus. You will draw these two every single time. The one that goes to the mirror will reflect through the focus. Nice. The one that already went through the focus will do the opposite. It will just go straight back from the mirror. So one goes straight, then through F. The other one goes the opposite way, through F, then straight back. You will see that the top of the image will be there, and you will have your arrow upside down over here, like that. There. That's an animation to show how it goes. You will have it like that, bouncing back, and there is my image drawn. Okay. A virtual image would be when you're beyond the focus and you cannot do anything about it. So you will continue to do what you're supposed to do. One line will go straight and then through the F. The other line will go through the F, but you will extend it back the way until it hits the mirror, and then it goes straight back. You will continue the lines on the other side of the mirror. Why is this not stopping? You'll continue the lines on the other side of the mirror, and the image will be there, amplified, much bigger. You can do it through the F, or you can actually have the other line through the C. You will get the same answer. So there are different examples. If you're beyond the C, this is actually the center. Like if it was a radius, if I made this into a big circle, that is not a circle, but let's assume that was a nice drawn circle. This would be my radius. It's not too important. This is the focus. And you will actually find that the radius is double the focus. We do not really need to know that right now. So just the idea of the drawings is what's important. So if it was in here, the image will be behind it, between the C and the F. If the image was beyond the F, it's always going to be an inverted image. These are all for this type of concave lens. And then you will have no image formed if it's on the focus. So this final one would be when it's on the C, the center point, the image will be exactly the same, but just opposite direction. You will have to be able to describe them. You have to know that is it larger or smaller? Is it the same side up or is it upside down? Where is the image going to be, closer, further away? And whether it's real or virtual. Real means you can see it on the same side of the mirror. Virtual means it's on the opposite side of the mirror. That's all it means. So to draw them, these are the different examples of how to draw all the diagrams if you had to do that. We are beyond the C. You can see you'll just follow the line going along through the focus. The other one through the focus and over here. You'll find that if you're beyond C, the image is always going to be smaller. It'll be real because it's on this side. This is the wrong side. This is the correct side. And it'll be inverted upside down. If it's on the C, just like in the previous example, you will see that you follow the lines through and you'll see that it meets at the exact same position. So it'll be the same size, upright, not upright, sorry, same size, upside down, which we call inverted, and it'll be real. If we're going between the C and the F, follow the same rule all the way back, keep following it, and you'll see the image is behind you, so it'll be a little bit bigger, and it'll be real, and it'll be inverted. If it's between the F and the mirror itself, you will do the lines like I mentioned earlier, one straight and through the F. The other one can go directly through the F and then hitting the mirror and then going straight, and you will get the image. Or if it's a situation like this where the image is not big enough, no problem, we can just go through the center instead. If you go straight to the center, you will find the image. So either way is acceptable. And in this case, the image is virtual, is bigger, and is upright. Convex, it doesn't matter where you are, it's not important, you will do the same idea. One can focus through, one will go through the C, and one can go straight and bend backwards, and then straight to the F, and you'll have your image. You can also go straight to the F and you'll get the same thing, straight towards the F, and then you'll end up banging it right to here, and the image will end up being in the same place. So like I said, you can use the C or you can use the F in a situation like this. I prefer to use the F, but it depends on the image that you're drawing. Couple of tips: the distance on the same side of the mirrors, we will call them positive. If the distance is on the opposite side of the mirror, it will be negative because it's a virtual image. For focal length on a concave mirror, it will be positive. Convex will be negative because all convex images are on the right hand side. If the distance is positive, it's on the same side of the mirror, it will be real and it will most likely be inverted. If it's negative, it will be on the opposite side, virtual and upright. So quick summary: concave and convex, the distance will be positive for real objects. Same with this, it will be positive for real objects. But you'll find that in convex is always going to be negative. Concave, you'll have positive for real images, negative for virtual images. Same thing, here we go. This is real on this side. And on the other side will be virtual. Virtual, that's supposed to say virtual. Positive side, negative side. That's all it means. Okay, focal length being positive and negative is not too important right now because we do not need to know the formula. We won't need to do any calculations, so we can ignore that for now. We can use concave mirrors for shaving mirrors or head mirrors to help make the image bigger for us so we can see what's going on. We can use convex mirrors for car rear view mirrors. You can have curved mirrors. If you're in a car park, you will see like a big mirror. It's like a dome and it's curved, so you can see everything on this side and everything on the other side as well. It kind of makes the field of view a little bit bigger.